Welcome back. In this video, I want to talk about separating equilibrium in insurance market. So we would like to focus on this first defining what is a separating equilibrium. So we have two types introduced in a very specific way where the only difference in the types is the probability of loss. We have a separating equilibria if two different packages can be offered to these types in such a way that no agent has a strict incentive to unilaterally deviate. So it kind of pays off to first know where the separating equilibrium is. So I'm going to take an approach of, if I was on an exam and I was drawing this, I want to take the approach of first quickly how I go about setting up this equilibrium, or how do I know what the separating equilibrium looks like, and then I want to justify it. Okay, so rather than justify it first and then find it, I want to effectively give you the equilibrium first. I give you a method how to remember how to get to that equilibrium fairly quickly, and then from then start to justify it. So we have good state, we have bad state, we have a usual 45-degree line, which is a full insurance line. Perhaps let's make this dotted. We have a no insurance contract, or no insurance package, or state of the world, if you like. We have the risky type, which have an actuarially fair odd line. We have a safe type, and by safe and risky, we simply mean a difference in the probability of an accident happening, where the safe one have a lower probability of risk happening. Okay, so we have actuarially fair line, and then let's assume that there's a lambda share of risky types. So therefore, we're going to have an aggregate fair odds line, or an average fair odd line. So of course, if lambda is very large, let's say 0.9, it will be something like this. If it's very low, it will fluctuate, right? So it will be somewhere here. Okay. So here is how I go about drawing or finding the separating equilibria. Once I've drawn this three together, I go ahead and make a tangent indifference curve for the risky individual. And I know that the risky individual is going to get full insurance. So I'm going to label that as the package for the risky. Okay. And where this intersects with the safe type, that's the package that the safe type is going to get. And there I can also draw an indifference curve, if I like, of the safe individual. Remember from a previous video, this indifference curve will be steeper. Note that both indifference curves clearly are above the no insurance, so both types would get it. So therefore, the answer is that the separating equilibria will exist if RS is offered. And by the way, we're also assuming R is only taken by risky types, and the safe one only taken by safe type. Now, we know that the risky individuals are indifferent between that safe option and the risky option, but we're assuming that that's what they're taking. Okay. So that's the first part. So the first part of this video is I want you to first be able to see, like, okay, this is the package. Now I want to be convinced that this is indeed the package that will lead to an equilibrium. What was the definition of an equilibrium? No agent has a strict incentive to unilaterally deviate. Okay, let's look at the insurance firms. Whichever insurance firm is offering R is on the actuarially fair line and is getting by the risky guy, so they make zero profit. Whomever's offering S, they're also making zero profit. So there's no incentives for any outsider to come in and offer these packages. Now the question, of course, is would anyone want to come in and do cream scheming here? Could any outside insurance or current insurance get a better profitability, right? Get a positive profitability. So what immediately comes to mind here is that this safe individual is getting actuarially fair insurance, but not full insurance. So maybe there is a way that we could offer them a better deal, right? So clearly, this all this area here will be a better deal for the safe individual and would be below their actuarially fair line. So if I were to put sort of like an alternative for the safe individual here, that is S prime here, okay, that might look appealing, right? So it would get all the safe individuals. The problem with that, of course, is that it will also get all the risky individuals. Okay. So that would actually not be profit maximizing. In fact, you will get a negative profit. Okay. And whether this particular possibility here exists or not, right, to make a positive profit will very much depend on where this aggregate fair odds line or average fair odds line is. Okay. And you could see that if I were to take another fair odds line that was like this, even though both would take it, it'd still be below that actuarially fair odd lines. And therefore, that separating equilibrium would not exist. So the separating equilibrium relies on being a large enough number of risky individual. Okay, so we want this to be close enough to the risky guys to be able for an equilibrium to exist. Now, again, why is it an equilibrium? Why don't I pick maybe some point for the safe individual that it's here, for example? Imagine that you say, well, what about, let me just clean this a little bit. What about if someone says, can I offer a slightly lesser point to the safe individuals? Okay. Right? So not where there's an indifference between the risky type and the safe guys, but they get an actually fair insurance, but even less insurance than they were before. Well, in this particular circumstance, a cream scheming possibility will arise. Because here you could see that a package here would be preferred by the safe individuals, would not preferred by the risk individuals, and you'd be making a profit because it's below the green line or the actuarially fair lines. So you can play around with these ideas, and then realize that that would be the only separating equilibrium that you could get. So and remember more generally, when you have a separating equilibria, because we have assumed free entry and exit, you know that one of the offers have to be here on the red line, and one of the offer has to be on the green line. And it must be that the risky offer is only taken by the risky person, and the safe offer is only taken by the safer person. So you could see you could have come initially, and you can do some exercise if you like, and say, well, what if I pick this R triple, right? And I pick this as a potential equilibrium. What will happen then, right? Um, and then you can think about like, is there possibilities of cream scheming where perhaps you could give something even better to the risky guys, but not full insurance. So, what's the moral of the story? You should understand what is a separating equilibria. You should understand how to draw separating equilibria fairly quickly because they almost certainly look very similar. So you should know how separating equilibria look like, and you should be able to draw it from scratch. And you should be able to argue that the separating equilibria will only exist if this share of risky types is large enough. And there are situations where there is no stable equilibrium, and therefore no such equilibrium exists. I hope you find this helpful. I will see you on the next one.